Hello everybody. In this video, I am going to provide the solution of SSB lecturer. As you know that this exam was held in the month of December 2023, and here I am going to provide the solutions. Okay, so let's first go to the first question. The first question was like this. It was given a parallelepiped, and the adjacent sides are OA is equal to 3 I cap and minus j cap, and the OB vector is j cap plus 2 k cap, and OC vector is 2 I cap plus 5 j cap plus 4 k cap. So we have to find the volume of this parallelepiped. So as you know that the volume of a parallelepiped is A dot B cross C. That means so so ultimately we have to solve a matrix element. Okay, so after solving this value, after solving this matrix, you will ultimately get a value like minus 22 unity. Okay, so if you observe this all the options, all the four options, then you will not find any value like minus 22. So it's a question of a for which the students are were given the grace mark. Okay, so no, don't worry, it was a grace mark question. So now coming to the second question. The second question was about the solenoidal nature of a vector. Okay, so a vector to be solenoidal, what is the main criteria? The main criteria is its divergence should be zero. So I have given some illustrations here of two vectors. The first vector is f vector, and if you see that this vector is gradually increasing if you go from left to right. If you see that this vector is in terms of magnitude, it is increasing and in a particular direction. Okay, whereas in this vector a vector, the magnitude is constantly remaining same, but as well as its direction also. So its magnitude is constant throughout the from this point of time to this point of time. Okay, so it's not increasing, but whereas for this vector a vector, it's increasing in a direction. So this vector has a divergence 0. Okay, whereas for this vector a vector, it has a divergence of 0. Okay, a vector has a no divergence, it is not 0, whereas a vector has a divergence 0. Okay, so for a divergence, as you know that if you put del dot r to the power n r cap, r vector is equal to 0, then this r vector can be written as r into r cap. Okay, so this r cap will be added to this r to the power n, and it will be r to the power n plus 1 into r cap. And using the formula, this is the particular formula, uh, del vector dot del dot r to the power n r cap will give you, after solving, I am not giving the solution of this particular equation. You have to remember it. Okay, so it will be n plus 2 r to the power n minus 1. So we have here we have r to the power n vector, r to the power 1. Okay, power, in this power we have r to the power n, but in this formula we have r to the power n. So ultimately we have to add another one. Okay, like del dot r to the power n r cap will be n plus 1. So in this n we have to put n plus 1 plus 2. Okay, so ultimately this will be n plus 3 r to the power n. And as r to the power n is, and r is not 0, r is not 0, that means r to the power n is also not 0. So n plus 3 is equal to 0, that means n equal to minus 3. So for this vector to be solenoidal, the n value should be minus 3, otherwise it cannot be. Okay, so now coming to the third question. The third question is about the contraction of a tensor. So it is asked to uh, a question like the general in general the operation of a contraction on a tensor reduces the rank of a tensor by how much. So it is the nature of a tensor or the property of a contraction of a tensor. And I have given the solution here like this. So it's the equation number 3, sorry, question number 3. It is partially visible, so let me name this question number. Okay, so it's 3. Okay, so uh, for to to give a illustration and the background knowledge of this tensor reduction or contraction of a tensor, I have taken the example of a delta, Kronecker delta. Okay, so Kronecker delta is a second order mixed tensor. So the main criteria is for to apply this contraction of a tensor, the tensor should be a mixed tensor. So mixed tensor are in this form. It has a upper prefix and then a lower prefix. Okay, okay. So if this any tensor has this type of notation, it must be a mixed tensor. Okay, so if you write this Kronecker delta, it will be del x to the notation j and divided by del x I. So if my j equal to I, then what happens? It will ultimately give you 1. So where, as you know, a scalar, 1 is a scalar. So if any scalar has rank 0, okay, so ultimately this Kronecker delta who has the order 2 becomes r- order 2 of rank of order 2 before when I was not equal to j. Before when I was not equal to j, its rank was 2. Okay, because it's a second order mixed tensor. But after I equal to j, when we make it I equal to j, then we are getting a scalar who has a rank 0. Okay, so what happens? Hence the rank is reduced by 2. Okay, rank is reduced by 2 because it has a the scalar has rank 2, and previously we have the rank of 2 mixed order tensor. Okay, so it will be the rank will be reduced by 2. So option B will be the correct answer. Now coming to the next question, question number 4. This was a question on complex integration. Okay, where the contour is of radius 4, and we are integrating this contour about the origin because z mod z equal to 4. That means z minus 0 mod equal to 0. That means we are doing this calculation about 0. Okay, so its solution is like this. So here is the number 4 question. This is the contour whose radius is 4 because it is given that radius is 4. Okay, radius is 4. And if you what happens, so to solve this question we have to first find out the pole of this question. The pole are uh, z equal to 1 and z equal to minus 3. Okay, so after find outing the pole, we have to examine whether these two poles are inside the contour or not. So if you see that as the radius of this contour is 4, that means ultimately these two poles are present uh, inside the contour. So we have to find the residue of both these poles. Okay, so after find out the poles for the pole z equal to 1, the residue will be 3 by 4. like this in this method, and for z equal to minus 3, the residue will be minus 11 by 4. It's a simple method. Okay, so if you sum them, as you know that for any integration, uh, by the when you do it by the help of our Cauchy residue integrals, then we have to multiply this residue with 2 pi I. Okay, so the sum of residue are r1 plus r2, and if we sum them, we will get minus 2, and after then the integration will be 2 pi I into sum of residue, and we will get minus 4 pi I. So this is the solution. So option D is the correct answer. Now coming to the fifth question, the question was asked about the Fourier transform of a delta function about x equal to 0, because it is del x. Okay, delta of x, that means we have to find at origin. That means this delta function is present at the origin. Okay, so the Fourier transform of this delta function is given like this. So as you know, this is the Fourier transform of any function where this is fk is equal to 1 by 2 pi minus infinity to plus infinity e to the power ikx fx dx. This is our function. Okay, and we want to find the its Fourier transform. This is the Fourier transform of this fx function. Like the Fourier transform of a time is a frequency. Okay, okay, or energy. Like this, we have assumed that this x variable as the Fourier transform is k in terms of k. It may be any quantity. Okay, so if you put this delta function e to the power ikx delta x dx, then after putting this delta function in this place, we have to apply the delta function formula or the property. What is this property? We know that minus infinity to plus infinity fx delta x dx, this delta x is at 0. That means the 0 point is present inside minus infinity to plus infinity, so it will be f0. Okay, so what we have to do, we have to apply e to the power ikx. This is our here in this x, we have to put the x equal to 0. So ultimately we will get e to the power ik 0. So e to the power 0 is 1, so we will get 1 by root over 2 pi. It's a constant. So like this, if you want to see the graphical nature, how it is transferred in the graphical way, then at x equal to 0, this is 0, the delta function is like this. It's a peak, like a tower. Okay, it's a tower, like a mobile tower. When you do the Fourier transform, then it will be a constant along the k, and this much height is how much? This is 1 by root over of 2 pi. Okay, when you do the Fourier transform, then it will be a constant